reading of the article, The Simple Electric Universe by Wal Thornhill. The article begins with a quote by Garrett L. Verschuer of Interstellar Matters. Quote, "Some people in each successive generation believe that theirs is the one that has at last seen everything clearly, that their insights point to the truth, the final answer. Yet scientific discovery marches on, and today's truth will become tomorrow's anecdotes." End quote. Since my last report, I have been in England, where I convened a meeting of people actively concerned with the electric universe and the problem of educating the public. Gaining attention for a simple electric model of the universe is a problem because the media is devoted to the science fiction of the Big Bang. Noted astronomer Fred Hoyle wrote prophetically in Of Men and Galaxies of 1964, quote, "More and more, the professions will cross over into the entertainment field. Those of us who are not employed directly in industry will come to realize that what we are really in is showbiz." End quote. Much earlier, George Christoph Lichtenberg was even more prescient. Quote, "A man cannot strongly enough ask of heaven, if it wants to let him discover something, may it be something that makes a bang. It will resound into eternity." End quote. For the sake of science, I hope not. The Big Bang was not discovered, but contrived by mathematicians following the proposal of a Belgian Roman Catholic priest and astronomer, Georges Lemaitre, for the origin of the universe from a primeval atom or a cosmic egg exploding at the moment of creation. The theory defies physics principles and is unrealistic, needing most of the matter in the universe to be invisible, not even dark, and a mysterious dark energy. Even galaxies must have mathematical figments, black holes, at their hearts to explain just a few of their characteristics. Hoyle believed one single, usually simple, observation could unseat a strongly established prejudice like the Big Bang. But when you believe in theories like the Big Bang, logic has no dominion, and any observation can be accommodated. The electric universe is developed upon plasma cosmology, which is a recognized discipline within the practical electrical engineering profession through the Institute for Electrical and Electronic Engineers, the IEEE. Refereed papers on plasma cosmology are published in the IEEE Transactions on Plasma Science. The freewheeling discussion in that journal is reminiscent of the science journals of more than a century ago, not the monoculture of the Big Bang today. My paper on the electrical nature of supernovae and stars was published there in 2007. It is curious that astronomers plot stellar colors and brightness like Alice through the looking glass. Left and right are reversed, which makes it difficult to see obvious connection between the electrical power arriving at a star and the star's color, size, and brightness. Unlike Big Bang cosmology, plasma cosmology is subject to experimental tests in the laboratory and follows the Lichtenberg experimental tradition. Any bangs it creates are real and noisy. Plasma cosmology can demonstrate with simple physical principles the electrical formation and behavior of spiral galaxies and stars without recourse to hypothetical dark matter and black holes. Almost the entire visible universe is composed of plasma, a gas where some of the atoms have lost an electron or two. However, unlike the gases we are familiar with on Earth, plasma reacts strongly to the presence of electromagnetic fields and is a better conductor than copper. Its behavior has been described as complex and lifelike. That should be a clue. The universe is principally an electrical plasma phenomenon. Electricity exists in space. Magnetic fields detected in space can only be generated by electric currents. Radio telescopes routinely map galactic magnetic fields, and their field configuration matches that found in plasma cosmology experiments. If science were the advertised open pursuit of truth, we should expect Big Bang cosmologists to be rushing to the plasma labs. Not a bit of it. They are principally theoretical mathematicians. We strike the artificial modern barrier of specialism. The cultural historian Jacques Barzun defined specialism as, quote, a piece of etiquette which decrees that no specialist shall bother with the concerns of another, lest he be thought intruding and be shown up as ignorant. Specialism is born of what the philosopher Arthur Balfour called the pernicious doctrine that superficial knowledge is worse than no knowledge at all. Rampant specialism, an arbitrary and purely social evil, is not recognized for the crabbed, guild spirit that it is, and few are bold enough to say that carving out a small domain and exhausting its soils affords as much chance for protected irresponsibility as for scientific thoroughness. End quote. From Science, the Glorious Entertainment. The plasma cosmologist Eric Lerner, author of The Big Bang Never Happened, says, quote, one of the most destructive features of the methodology of the Big Bang is that it conveys the idea that only people versed in extremely complicated mathematics can understand the universe. This is, of course, the argument of the emperor's new clothes. If you can't see the emperor's new clothes, you must be either stupid or incompetent. End quote. Engineers are neither stupid nor incompetent. Much of the hyped success of science over the last century can be attributed to engineers, and it is engineers who tend to prefer the real-world simplicity of the electric universe to the metaphysics of the Big Bang and black holes. A signature of a good theory is its simplicity. Bob Johnson, one of the participants at the London meeting, concluded, quote, I think the electric universe is actually very simple, end quote. In essence, everything hinges on the question of whether or not electricity exists in space. The mainstream view is that it does not. We argue that it does. Everything else flows from that. What we are attempting to do is bring about a scientific revolution, the electric revolution. This revolution will have as far-reaching consequences as the Copernican revolution, which was also based on one simple idea: is the Earth or the Sun at the center? Like the Copernican revolution, the data can be interpreted in both ways. Copernicus did not phrase his argument that the Sun was at the center. He merely suggested that it was an awful lot easier to interpret the data if, for the sake of calculation alone, one pretended that it was. In the same way, I believe we are essentially suggesting that it is an awful lot easier to explain the observed behavior of the universe if one allows electricity to have a role. Yes, you can develop a gravity-only model that gives the right answers, but having to live with 96% of the resulting universe being dark and unobservable is no better than having to have multiple levels of epicycles to explain the planetary motions around the Earth. Quote, that's why it's so simple. Just assume electricity is there and it all becomes a whole lot easier. End quote. History will show that our present Big Bang cosmology is an unfortunate accident of timing. The foundations of the Big Bang story were being laid down early in the 20th century. At the same time, electric lights were just being introduced, and the study of electric discharges in gases was in its infancy. The result was that Einstein's new esoteric geometric theory of gravity that treats empty space as an object capable of being warped was combined with a curious interpretation of the redshift from faint extragalactic objects, not favored by Hubble himself as being physically likely. to produce the notion of an expanding universe. The fact that this defined a principle of physics in creating matter from nothing at the beginning, or Big Bang, seems not to have concerned theorists. It should have. Invoking the ultimate free lunch is not science. On the other hand, based on observation, the electric universe assumes a universe of unknown age and extent. Quote, "Who indeed are we as a species to dare ask such mighty questions as concern the origins of the universe, and in unique arrogance believe that we have the correct answer within cosmic microseconds of the asking?" End quote. Garrett L. Verschuer. The intellectual hubris of Big Bang theorists is shocking when we find that science cannot explain the simplest phenomena associated with matter. Mass, gravity, magnetism, and light are a mystery. We have equations that describe what happens when a charged particle is accelerated, when you drop something from a height. A current passes down a wire, and light strikes a surface. But mathematical descriptions do not constitute a physical explanation. Meanwhile, the last century has seen great progress in understanding the phenomena of electricity in vacuum tubes, arc lamps, arc welders, industrial electric discharge machining, and ultra-high energy experiments at Los Alamos National Laboratories and Sandia Laboratories. Electrical engineers were the first to see striking parallels with astronomical phenomena, beginning with the Earth's aurora. The Norwegian Christian Birkeland in the early 1900s set up an electromagnetic observatory inside the Arctic Circle. He associated the magnetic effects of aurorae with electric currents flowing between the Sun and the Earth. His electrical terrella, or little Earth experiments, were able to reproduce the features of aurorae, sunspots, comets, etc. The big lesson from the terrella experiments is that they required external electric power generated some distance away. In recent years, his name has been applied to the electric currents discovered in space, Birkeland currents. Engineers find it easy to light our cities with electrical power generated at some distance from the city. It never occurs to astronomers that nature uses the same simple method of lighting galaxies. They have never considered that stars might be a cosmic electrical phenomenon, like streetlights, tracing the path of power lines. It was Dr. Charles Bruce, a fellow of the Institute of Electrical Engineers as well as of the Royal Astronomical Society, whose work on lightning allowed him to identify electrical activity on the Sun, on stars, and in galaxies. The Nobel Prize-winning Hannes Alfvén was trained as an electrical engineer, but went on to produce much of the theoretical underpinning of the electrical behavior in the electric universe. An article about his work with the title Alfvén's Electric Universe appeared in the Boston Globe on Monday, March 20th, 1989. Alfvén insisted that it was of prime importance to understand cosmic circuitry, but astronomers ignored him. So discoveries about lightning and auroras continued to surprise physicists, even in this space age. Perhaps there's a good reason for this. Our earthly experience is one of solids, liquids, and gases. The region we inhabit, between the ionosphere, some 80 kilometers above us, and the surface of the Earth, is one of the rarest environments in the universe. We inhabit part of the 0.001% or less of the universe, where plasma is not to be found naturally except in the lightning bolt and occasional aurora. Plasma has been termed the fourth state of matter, but in view of its ubiquity, it would be better termed the fundamental state of matter. It is a state where neutral atoms are mixed with charged particles, positive and negative. These particles may be as small as electrons and protons, or may range up to the size of molecules and dust particles. In a gaseous plasma, like we find throughout the universe, the charged particles respond more strongly to electromagnetic forces than they do to mechanical or gravitational forces. One of the results we see in lightning is the constriction of electric currents to form long filaments. And the filamentary nature of plasma in space is well documented. No dark matter, sprinkled where required to save a theory, is necessary. The electric universe assumes that nature is not willfully hiding her secrets. The complexity we observe in the universe comes from very simple electrical principles, some of which can be tested with very simple apparatus. Science is open to everyone. The visible universe is an electrical phenomenon, from the structure of subatomic particles to the superclusters of galaxies in deep space. The electric universe model is simple enough that it can be taught to young children, but it first requires that cosmology is actually included in the science curriculum and then treated with a reasonable level of importance. For the more mature student, the science curriculum should include studying the behavior of electricity in gases. Everyone is familiar with lightning. Most have seen fluorescent and neon lights. And the writhing, lifelike filaments in the novelty plasma ball are a favorite with kids. But familiarity with lightning and neon lights does not equate with understanding. Lightning and the plasma behavior inside those glass tubes and balls are a mystery to almost everyone. Yet the environment inside those objects most closely equates to that of the rest of the universe. The outgoing president of the International Astronomical Union, Catherine Czarsky, said, quote, "I think young scientists should guard themselves against brainwashing. They should look beyond the road maps, even if we put the best we know in them. Also, they should resist specializing too much at the cost of the big picture. The best way to escape the bandwagon effect is to look at things from a distance, to connect different ideas." End quote. It is time for another idea in astronomy. The electric universe is a new big picture of the universe that looks at things from a distance and connects different ideas. If science has become showbiz, the broad panorama of the electric universe is fitted for an IMAX theater to show like nothing else before it. The electric universe releases us from the confining eggshell of Big Bang metaphysics and propels us into the real universe. Our future depends on it. The possible scientific, technological, and cultural advances will be, as Arthur C. Clarke so ably expressed it, indistinguishable from magic.